Hello, I'm Sebastian. Welcome to 9 Trees podcast. Today, I will summarize and review the book, What is Real? By science writer Adam Becker explores one of the strangest success stories in modern knowledge. Quantum physics works extraordinarily well, yet physicists still argue about what it says the world is. Rather than treating the debate as a niche philosophical distraction, Becker presents it as a central thread in the history of 20th century physics, shaped by personalities, politics, and institutional power. The book traces how certain attitudes, especially the idea that no deeper account is needed beyond calculating measurement outcomes, became dominant, often at the expense of alternative approaches. Becker introduces major interpretive camps such as Copenhagen, many worlds, pilot wave theory, and spontaneous collapse, while showing how each attempts to reconcile quantum predictions with everyday notions like realism, causality, and locality. Written for curious non-specialists, it combines historical narrative with conceptual explanation, aiming to clarify why the question of what is real in quantum mechanics remains open and consequential. I will give you key takeaways from this book. Firstly, how Copenhagen became the default story. A central theme is how the Copenhagen perspective came to be treated as the standard attitude toward quantum mechanics, even though it is less a single theory than a cluster of habits and slogans. The book situates this rise in the early 20th century, when the new quantum formalism produced correct predictions but resisted intuitive pictures. Figures associated with Copenhagen promoted an approach that prioritized calculation and measurement results over claims about underlying reality, and the broader physics community often adopted it as a pragmatic stance. Becker emphasizes that this was not a purely logical outcome of the mathematics, it was also a cultural outcome shaped by authority, pedagogy, and the pressure to get on with productive work. In this telling, alternatives were frequently dismissed as metaphysics or as attempts to restore classical certainty, even when they were mathematically coherent. The topic also addresses how the rhetoric around complementarity, uncertainty, and the primacy of observation hardened into a kind of orthodoxy. By examining that history, the book invites readers to separate what quantum theory predicts from how we choose to interpret those predictions, and to recognize that the default story is neither inevitable nor universally accepted. Secondly, Einstein and the realist challenge to quantum orthodoxy. Another major topic is the sustained realist critique associated with Einstein and others who resisted the idea that quantum mechanics should renounce a deeper description of nature. Becker presents this not as a nostalgic refusal to accept novelty, but as a principled concern about whether the theory is complete and whether it permits a coherent account of physical reality. The debate over completeness, hidden variables, and the role of probability becomes a lens for understanding what is at stake when physicists say a theory is about the world rather than merely about our observations. The discussion naturally touches on entanglement and the tension between quantum correlations and locality, showing why the argument is not merely semantic. Becker portrays the historical dynamics of these disputes, including how certain realist objections were marginalized for decades and how later theoretical and experimental developments revived them in new forms. This topic helps readers see that the foundational questions were present from the beginning, and that many of the most famous puzzles, including the measurement problem, are not manufactured by philosophers, but arise from taking the formalism seriously. The book uses the Einstein-centered critique to highlight how scientific progress can include unresolved conceptual conflicts, not just accumulating successful predictions. Thirdly, many worlds in the measurement problem. The book devotes substantial attention to the measurement problem, the mismatch between smooth, deterministic quantum evolution and the apparently definite outcomes we experience. In standard textbook practice, measurement is treated as a special process, but that move raises questions about what counts as a measurement and why it should have privileged status. Becker uses this tension to motivate interpretations that try to remove the special case, with many worlds as a prominent example. Many worlds keeps the basic quantum equation universal and treats outcome definiteness as branching rather than collapse. This approach promises conceptual economy by avoiding ad hoc measurement rules, but it confronts readers with a counterintuitive picture of reality and demands careful thinking about probability and the meaning of outcomes. Becker emphasizes that many worlds is not a fringe idea. It has attracted serious scientific advocates and has influenced discussions around decoherence and quantum information. At the same time, he highlights the interpretive costs, including debates over whether branching worlds are literal and how to justify the usual statistical predictions. By framing many worlds as a response to a precise technical problem rather than as science fiction, the book clarifies why interpretive disputes persist even among experts who agree on the calculations. Fourthly, pilot wave theory, non-locality, and a different kind of clarity. Becker also explores pilot wave theory, often linked to de Broglie and Bohm, as a fully realist alternative that restores definite particle properties guided by a quantum wave. In this framework, randomness reflects limited knowledge rather than fundamental indeterminacy, and measurement becomes a physical interaction like any other. The appeal is that it offers a clear ontology. There are particles, and there is a guiding wave, and the theory specifies how they move. The cost is that the theory is explicitly non-local in the sense that distant systems can influence one another through the guiding dynamics, a feature that becomes especially salient when discussing entanglement. Becker uses pilot wave theory to show that the standard narrative, that realism must be abandoned, is not forced by the data. Instead, different interpretations distribute the conceptual burdens differently. This topic also illustrates how sociological factors influenced which ideas were pursued, funded, or taught, and why certain approaches remained obscure despite being mathematically viable. By comparing pilot wave theory to Copenhagen and many worlds, the book helps readers appreciate that the central question is not whether quantum mechanics is correct, but which picture of reality best makes sense of its correctness, its structure, and its structure, and its structness, its structure, and its strange correlations. Lastly, collapse theories, information talk, and what counts as explanation. A further topic is the family of approaches that modify or reinterpret quantum theory to address the measurement problem more directly. Collapse theories introduce objective mechanisms that make superpositions decay into definite outcomes, attempting to turn the vague notion of measurement into a precise physical process. Becker discusses why such proposals matter. They can, at least in principle, yield testable deviations from standard quantum predictions, making interpretation overlap with empirical science. Alongside this, the book considers the modern habit of talking about quantum mechanics as primarily about information, knowledge, or observers, an attitude that can feel elegant but may also dodge questions about what exists independently of us. Becker is attentive to the difference between using information as a useful tool and claiming that information is what reality fundamentally is. This section broadens the argument from specific interpretations to a methodological question: what should physicists demand from a foundational account? And when does pragmatism become avoidance? By contrasting collapse models, information-centered viewpoints, and more realist ontologies, the book encourages readers to evaluate explanations by their clarity about what is real, their fit with the formalism, and their openness to experimental scrutiny, rather than by their conformity to a prevailing style of thought. In conclusion, this book is best for readers who enjoy big scientific questions and want more than a list of quantum oddities. Curious non-specialists, STEM students, and practicing scientists who have only seen the shut up and calculate attitude in coursework will benefit, as will philosophy-minded readers who want the physics history behind modern debates. Its practical value lies in improving how you think. It teaches you to separate prediction from interpretation, to notice hidden assumptions about observation and reality, and to evaluate explanations by their conceptual and empirical commitments. Those habits transfer to other domains where models work well, but their meaning is contested, from neuroscience to economics. Compared with many popular quantum books that lean on mystique or overplay consciousness, Becker focuses on concrete interpretive options and the human story of how some ideas gained authority while others were sidelined. It is worth buying because it combines readable narrative with a clear map of the main positions, giving you enough structure to follow current discussions without being misled by slogans. If you want an informed tour of why quantum physics still raises unfinished questions about reality, this is a strong and intellectually honest guide. If you would like to support Adam Becker, you can buy the book through the Amazon link I've provided in the podcast description. After reading the book, please let me know what you think and share your thoughts. See you around.